Good afternoon. We will be starting the next session about the instructions of 8085 microprocessor. Now, what do you mean by the instructions of 8085 microprocessor? The instruction is a binary pattern which is designed inside the microprocessor to perform a specific function. What is an instruction? It is a binary pattern. Binary means zeros and one pattern, which is mainly used by the microprocessor in order to do a specific function. This entire groups of the instruction that microprocessor supports is called as the instruction set. Now 8085 has approximately 74 instructions which are further divided into different forms, and then they become 254. Okay, but in short they are categorized into 74 instructions. Now each instruction is represented by 8-bit binary value, which is called as the opcode or instruction byte. So there are two types of languages which are used by the 8085. The first one, the earlier one, was used as a machine language, which was actually in the binary form, zeros and ones, and which was difficult to remember that particular code. That particular code is for which operation. It was really difficult to remember. That's why we use the assembly language. So in the assembly language, we use the mnemonics, or I said opcode, which are further converted into the machine language by the assembler. Okay, now we are going to study this particular assembly language of 8085. Now we will first see what are the groups of the instructions, and the groups of the instructions are actually depend upon the or according to the functions of the instruction. What that instruction does, what is the function of that instruction, according to that the instructions are divided into 5 groups. The first one is data transfer group, then the second one is arithmetic group, then the third one is logical instructions, fourth one is branching instructions, and the fifth one is machine control, stack related or IO related instructions. Now I will briefly tell you about this, and in detail we will see it later on. Now what does the data transfer group instruction do? Actually I will give you one example of each group, and then you will come to know. Now data transfer group instructions, what do? They transfer the data from one place to another. Now which is that place? Register to register, or from the memory to the register, or input or output devices to the registers, and vice versa, that is from registers to memory also, or registers to the output devices also. Now actual data can also be transferred to the registers. Like suppose if I tell you to bring 5 chocolates, you know how many chocolates exactly you want to bring. That is 5 chocolates. Okay, so that is nothing but your actual data. Similarly, whichever data has to be transferred to the register can be given in the instruction itself. So actually it copies the contents of the source to the destination, and while copying it, the contents of the source are not modified. You can say, since we use transfer, they are not actually moving the contents of source to the destination, but what they are doing is they are just copying the contents of the source to the destination. So source and destination will have the same contents now. Now for example, I will give you one mnemonic which is called as MOV A, B. So MOV stands for move, A is the name of the register, and B is the name of the register. So in this case, the source register is given as a B register, and the destination register is given as the A register. So the detailed form of move instruction we will see later on, but right now move A, B, in this case source is B and destination is A. So suppose A has 05, that is 5 is the data which is in B register. Now it is 8-bit number, so you have to write the 2-digit value. Then A has 0, for example, so 2 digits 00. Then after execution of this instruction, then A register, that is accumulator, will also have 05. and B also will have 0, 5. So here the data is transferred from B register to A register. Generally, data transfer group instructions, they do not affect the flag register, because the flag register is mainly affected by which instructions? Arithmetic and logical instructions. After you do arithmetic operation, the flag register will be modified. Arithmetic instruction groups, if you see, it will do all arithmetic operations on data like addition, subtraction, incrementing, decrementing, and so on. Now, one operand has to be in the accumulator in that case, always. Okay, and this answer will be always stored in the accumulator. The other operand, suppose there are data. One data has to be in the accumulator. The other data has to be actual data or the register contents or the memory contents. Depends upon where your destination is. Or you can say where your other data is stored. Okay, not destination, other data is stored actually. Now in this case, suppose if I say ADDB, so ADD is nothing but your opcode, that is add, okay, and B is nothing but the register. So what it will do, it will add the contents of B register to the A register, and then the answer is stored in the A register. So whatever is there in B register and whatever is there in A register will be added together. Always with the A register contains the register of the specified register will be the contents of the specified registers will be added. The answer will be stored in the A register. And hence here B register will, so for example, B register has 05, A register has 05, 05 plus 05, what answer you get is nothing but 08, right? So that answer is now stored in accumulator. And the B register contents remain same, they do not change. So here the contents of B register are added into A register and the answer is stored in the A register. This is how the addition will be done. This is for example in B, this is for example in A, the answer will be in E. Detailed study will be done later on. Right now just we have to remember what are the groups of the instruction. The logical instruction group, in this case, as you know, what are the logical operations? ANDing, ORing, XORing, complementing, comparing, all these are logical operations which are done by the instructions in this group. So the instruction which does ANDing operation is called as the logical instruction. So one operand again has to be in the accumulator. The answer is stored in the accumulator, that is A register. Another operand can be actual data or register contents or memory contents as it was in the arithmetic operation group. So for example, if I say ORA, this is the mnemonic, ORAB. So ORA, and this is the name of the register. So what do you mean by this? Or the contents of B register with A register. So OR operation you have to do. So what happens in the OR operation, if one of the bit is 1, output will be always 1. So if B is 5 and A register contains 03, then after execution what will happen? 05 is ORed with 03. So the answer will be, for example, the answer will be 07. Here it should be 0, 0, 0, 0, 0, 1, 1, 1. Okay, that is nothing but your logical instruction. In case of branching instructions, why they are used? Usually the instructions are executed one after another, right? One after another. That is the normal sequence of the instructions. Sequentially they are executed. But when you want to alter the normal control of the flow of the instructions, then we use the branching instructions. There are two types of instructions. One is called as the conditional branching and the second one is called as the unconditional branching. So conditional branching will check the condition. Whose condition? The flag registers, flags condition before altering the normal sequence. And unconditional branching, they do not check the condition before altering, they have to just alter the normal sequence. For example, JMP is the unconditional jump, correct? So unconditionally it will go to the desired instruction. Okay, it will suspend the normal sequence and it will go to the desired instruction. JC, jump if carry flag is set. If the carry flag is set, then only it will go to the desired instruction. So it checks the condition of the carry flag and then transfers the control. Machine control and stack or IO related instruction is another group of the instructions. So basically whatever instructions are given to the microprocessor will be under this category. So for example, HLT, that is nothing but halt. That means the microprocessor has to suspend or stop the normal sequence of the instructions. Then this is nothing but machine control instruction. There are stack related and IO related instructions also in this group. That example we can give it later on when we are going to study in detail what are the machine control and stack IO related instructions. Okay, that is for this session now. In the next session we will see data transfer group of instructions. Thank you.